to x equals 0. Okay. So I'm going to worry about what happens between 0 and 1. Well, I have this function x squared. Okay, good. I've graphed x squared once today. I think I remember what it looks like. Between 0 and 1, that's the only part of my x squared graph I want. So between 0 and 1, if I want to, I can just take a snapshot of what I have here, cut it out, paste it in over here in the appropriate place. Okay? Over here, I only want the stuff that technically is in this box. Again, the box is not to scale, so it is skewing our picture a little bit. But that's the shape that I want to go right here. Okay? If I need to, I can plot some points. At x equals 0, x squared equals, that's right, 0. Good job. You said that. Get on it. So at 0, I get 0. Okay? And then if I need to, I can plot the last value there. At x equals 1, x squared equals, there you go. Good job. So this is what my graph looks like between 0 and 1. Okay? For my x squared between 0 and 1, this is what I get. All right. Now we take a look at our last part here. Y equals 1. For everything greater than x equals 1, my graph says y equals 1. What does that look like? Horizontal line. That is our horizontal line. It continues on at 1 forever. It is a constant value, a constant function. We get this horizontal line in this way. And there it is. There's our graph of number 3. There's the graph that we get from the 30. All right. Questions on graphing these kind of things? I realize that lots of you probably have graphing calculators or other methods of graphing these things. You are welcome to use those on your homework, on the online quizzes. You're welcome to use that stuff. On in-class exams, you are not allowed to use those things. So you need to figure out a better way of graphing these things if you've relied on your calculator for a long time. Okay? You need to find some new ways of adjusting to graphing in this way. All right. Now the next thing we're going to look at, again, sort of deals with this graphs, deals with functions a little bit more. We want to be able to identify certain aspects of the functions. Okay? In calculus, we're interested in how functions behave, how they change. And some of the things about those graphs that we're interested in is where do the graphs increase and where are they decreasing? Okay? So these are two aspects that we're going to learn a lot more about as we progress through the class. But with these functions that we have on the board, let's take a moment or two and let's sort of identify what does it mean to say a function is increasing? What does it mean to say a function is decreasing? How can we identify that on graphs like this? Okay? So the first thing we need to do is we need to talk about what is the definition of increasing. And in mathematics, because math people are very anal, we have this need to be 100% correct. We have definitions that reflect that. So when we're going to talk about increasing, what we're actually talking about is we're talking about a function increasing on an interval. Okay? So along a collection of values, we're going to talk about a function increasing along a collection of values. So a function f of x is increasing on the interval ab if, okay, so let's think about how can we come up with a good definition of an increasing function on an interval. What does it mean to say it's increasing? Well, let's come back over here to our graphs or pictures for a moment. Okay. One thing we talked about here, number 2 here, we all sort of had the idea that this is in fact an increasing function, right? This line is increasing. Okay? Now, what does that mean to you? To say that this function is increasing, how can you sort of give me sort of a mathematical or a logical explanation of what it means to say this function is increasing? As a goes higher, what's a and what's b? Okay, so as the inputs go up, the outputs go up. That'll work. I can do that one. All right, so we need to take that and we need to translate it a little bit into a slightly different mathematical term or or a slightly different mathematical sentence. You said as x goes up, y goes up. All right, let's see if we can do that. So if x1 is less than x2, right? As the x values go up, what happens to the y values? The y values are f of x1 and f of x2. If it's increasing, what's the relationship between f of x1 and f of x2? F of x1 is going to be less than f of x2. This is our definition of increasing on the interval a to b. If x1 and x2 are in this interval, then this function is increasing here if it has this property. All right. So, if we take a moment here and look over at our graphs that we have, can you take these three graphs and can you identify for me in each of these three where these functions are increasing? The first one, where is y equals x squared increasing? My hearing's going. I'm going to turn my hearing aid up. 0 to 7. Okay, go ahead. 0 to infinity. All right. So we look at this graph here. We notice that in this particular graph, this thing is increasing as long as the values that I'm putting in are bigger than 0. Okay? So 1 here is increasing on the interval from 0. Okay? Yes?
Okay, with number 1 then, doesn't your graph eventually just literally go vertically straight up?
It never will actually be vertically straight up. I mean, you have this intuition of what the graph of x squared looks like. It's this U function, it's this U shape. But one thing you can do is that if you zoom in close enough on any little bit of that graph, no matter how far out you get, it's always going to have this slight bend to it, this slight, sort of curve that's moving in an upward direction, but it's never actually going to be vertical. Good question. Okay. So there's increasing for the first one. What about the second one? Where's the second one increasing? Okay, so on the interval, it's increasing where? Right, increasing on minus infinity to positive. Very good. Okay. And how about the third one? In the third one, there's only one place where it is increasing, and that is between 0. Go ahead.
Is it not increasing on the left side?
No, because again, if we look at what's going on here, the value, if, for example, if we look at the left side here, we take -3, right? -1 is greater than -3, right? -1 is greater than -3. What is f of -3? What is f of 1, of -1? 1. Is 3 less than 1? Okay. So that's where it violates our increasing definition.
If you look at a graph, it's like reading the book. You go from left to right.
Right, unless you're, Arabic or something, and then you go on the other way. So, if you guys are doing math in the wrong language, that may have some problems. It's English. All right. Okay, so we have increasing, not too bad. As we move through the course, we'll find there are different techniques we can utilize to identify when a function is increasing and decreasing. For now, we'll try to use these graphs as much as possible. Calculus is all about learning new techniques to do things, make things easier, and the techniques we'll learn will make things like this easier. We won't have to worry so much about graphs. We'll have more analytical tools that we can utilize to do these same things. Okay. All right, so definition of increasing, not too bad. What if we switch it around now and ask about decreasing? Well, we're going to talk about a decreasing function. What do you think the difference is? In a decreasing function on an interval, Again, we're looking at